this is our robot, or uh, technically it's not quite right. The wheels are oriented a little bit wrong, but we can just focus on one of them and say that we're viewing it from the underside. So in that case, the wheels would form a diamond, and this specific wheel is the back left from above, or in our case, the back right from below. And when the wheel rolls, it's going to, because of the rollers, end up exerting the force perpendicular or parallel, not perpendicular, parallel to the axis of the rollers. And this picture of the wheel is not quite at the right angle. So this arrow is at the right angle, but the picture isn't. So it's parallel to the direction the rollers would really be going. And it's at a 45-degree angle up and to the right, or forward and to the right. And similarly, on the other side, it would be at a 45-degree angle to the left and up, like on the other back wheel. And if we also factor in, well, first we can combine these two and see that they would have a net force going forward because they would cancel each other out horizontally. And if we add in also for the two front wheels, because they would also have one going forward and to the left and one going forward and to the right, those also cancel each other out, and you end up with a total force pushing the robot forward. But if we decrease the force on the wheels that are moving the robot left, then the force will not entirely be canceled horizontally in the right direction. So there will be, here when they're equal, it's perfectly canceled out left and right. But if it becomes less force to the left, then the right is no longer canceled. So the net force is leaning more toward the right now. And that's how we get the robot to go at angles. So with this picture, we can kind of draw in this triangle on it, which is going to be helpful for calculating how powerful each of these motors need to be in their direction, because they need to exert less force or more force depending on which way we want the net end force to go. So we can, to do that, use some trigonometry, where if the angle here is the angle we call theta, then the power of the motors pushing toward the right, which is when that's normalized to this hypotenuse of 1, because the motors only take values between 0 and 1, or between -1 and 1 technically, then that's going to be, this power for the ones pushing to the right is going to be cosine theta, and the power to the ones pushing to the left is going to be sine theta, just because that's the definition of trigonometry. But the angle, the way that we can get it from our controller, is going to be measured from here, from horizontal pointing to the right. So the angle that's like our heading that the controller stick gives us is going to be this whole thing. But we can figure out theta because we know from what we defined earlier that the wheels are at 45-degree angles. So this angle between the wheel and horizontal is going to rotating the wheels force and horizontal is going to be 45 degrees. So then, if the whole thing is whatever angle, our given heading, and this is 45 degrees, theta is going to be our heading angle minus 45 degrees. And so from that, all that, we can get a few steps to write our program. So first we want to get our heading angle, and to do that we can use a function in Java called atan2, which will give us this heading angle if we tell it the y value and the x value of the joystick. Like say the joystick is here, and that has this y value and this x value. And atan2 is a function that will just tell you based on those what the angle is. So it will find you this angle. And that gets us the heading angle. So then from this formula right here, we can calculate the angle we're doing the trigonometry. And then we just set the motor powers. So in this case, the front right and back left are the ones pushing toward the left. So they will use the sine of the angle. That will be just their power. And the front left and back right, which are going to be the ones pushing to the right, are going to be the cosine. And so these two pairs will always be in pairs, but we may need to invert these two if it doesn't quite work right. And the easiest way to do that is just trial and error. So now we have our math all figured out. It's a pretty simple program to write. We have just this skeleton that I've kind of cleaned out with just the default stuff that we have from the program and a blank loop. So every 40 milliseconds it will exit so that it will update. And it will do that once we press the start button and stop that when it stops. When we press the stop button, just initializing and defining our robot that we're going to use. So each update, we want to start with the thing we're focusing on now, which is just the movement. And we want to define a few variables we're going to use. So first, we are going to need the left joystick's y-axis, because that is what's going to tell us the y-axis of the left joystick. And we want the left joystick's x-axis also, as those together will give us where it is, where the controller x-axis, left axis, is pushed to. So we'll know the location that you're pushing it in the direction. So that will tell us what direction we want to go in. And we want to set both of these just equal to some values that we can get from this built-in thing called gamepad1. And we want its left stick y and its left stick x. And I've actually found in my programming that we need to invert both of these. So yeah, to work right. Now these are red because we don't actually have these variables defined. So you could do it either in the loop or here. I'm going to define them up here because that's the way I like to do it, but it doesn't really matter. And we're just using a double because that's like a decimal number that has twice as much precision as a float. Then once we have those defined, we can use them to find the heading. So we can make a heading variable equal to that function that we talked about before, which is math.atan2. And the values we want to plug into it are the left joystick X and the left joystick Y, and you might need to swap the order of these. You guys work quite right. In the end, we need to just define this heading variable. We want it to be a double. And we don't need to give these a default value because Java trusts us like that. So once we have our heading, we can find the angle we're going to be doing our trigonometry on. So we can make another variable, trig angle. And like we said before, that's just going to be the angle from the controller stick, the heading, minus 45 degrees. So that's going to be heading minus, and then the math functions in the math library of Java actually give and take values in radians, which are just like a different unit for measuring angles from degrees. So to convert 45 degrees to radians, that's just math.pi divided by 4. And we need to capitalize pi, and you can't go wrong with parentheses in Java. And then again, we need to define our variable trig angle. These next two, my notes say to define them in the scope of the loop. I'm not sure the particular reason for that, but we have two more variables, and these. Notice how each of these lines it uses the variable from some of the variables we just made. So like this one used these, this heading variable used these, this trig angle used the heading. So now we're going to use the trig angle for these functions. So that equals, this is the cosine, cos, so it equals math.cosine of the trig angle. And then similarly, the sine is going to be math.sine of the trig angle, because that's what we decided would be how, that's what we worked out would be how we got our values from the triangle. Then you can do a little trick in Java that I like, where you can define multiple variables on the same line by putting commas. So we want to define a bunch of variables for the powers of the motors, and I'm just naming this one BRP for back, right, power, because BRP is a nice short name. So that should be equal to the sine, but you might need to switch this around depending on if I messed up in my math in the other video. And we only need to say double ones to define both of these variables, because I'm also defining another one that FLP equals sine also. Unlike in C# or languages like that, you do need to have a separate equal sign for each of them. That's just in case you're wondering about other programming languages. And then we can undo the same thing again. I'm just doing it on a different line for like organization, because we're setting them to a different value. Because the back right and the front left should be the same, and the back left and the front right should be the same, but those are different from each other. Then there's only one more step, really, which is setting the motor's power. I probably should have been commenting this whole thing. And to do that, we can just do our robot dot front left motor dot set power, and set that to our FLP, because that's front left power. And then we copy paste this line 3 times, so now we have 4 total. And we want to set BRP, BLP, and FRP. And then, of course, we need to change what we're setting it for, so this should be front right. This should be back left. And this should be back right. And that's